Well, turbulence is what planes experience when they encounter vertical airflow. So we're all used to horizontal airflow, and the jet stream, in fact, in the atmosphere is horizontal airflow, but it can become unstable and develop a growing perturbation which contains upward and downward motion as well as horizontal motion. And when these upward and downward airflows impact upon a plane's wings, they will push it up and down and left and right and bounce it around, and that is what causes clear air turbulence to form.
Now, there's some good reason, some good evidence to believe that climate change may have an impact on turbulence. What is that?
Climate change is not only causing it to get warmer here at the bottom of the atmosphere where we live, climate change is also changing the basic structure of the atmosphere 10 kilometres above our heads where planes fly. And in particular, it is making the winds associated with the jet stream blow more strongly, and that is increasing the destabilising impact of these winds and increasing the susceptibility of the atmosphere to the kind of instability that causes turbulence.
So how have you addressed this question? How have you looked into the future to see whether or not turbulence might increase under a future where we've got more carbon dioxide in the atmosphere?
We've taken supercomputer simulations using one of the world's best climate models, which was developed by Princeton scientists, and we've taken two simulations. A simulation of the pre-industrial climate, when the CO2 was much lower, and compared it to a simulation of a future climate in which the CO2 is doubled, which is expected to happen roughly by the middle of this century, perhaps the 2050s. And we've used some mathematical formulations to calculate the turbulence in these two computer simulations and compare them.
And what do you find? What are you seeing in those simulations?
There are two main things we found. First, the average strength of turbulence we can expect to increase by perhaps between 10 and 40% by the middle of this century, which is slightly worrying, but probably just means a few more drinks knocked over and a minor nuisance, slightly less comfortable flights. Perhaps more worryingly, the second thing we've seen is most likely a doubling, we can expect, of the probability of encountering what we call moderate or greater turbulence. This is turbulence that is strong enough that you would definitely feel it on board a plane. Seatbelt signs would come on, you'd have great difficulty walking, food service would have to be stopped. And we're seeing in these computer simulations that the amount of airspace containing this kind of turbulence is most likely to double by the middle of this century because of climate change.
You've been looking at particular areas in the atmosphere, haven't you? I mean, because turbulence is more frequent in certain areas of the atmosphere. I mean, you've been looking particularly at the North Atlantic. Yeah?
The North Atlantic flight corridor is one of the busiest in the world. It contains 600 flights a day, 300 westbound and 300 eastbound, and that makes it a very busy piece of airspace. So it's particularly important to airlines and to passengers, and so we focused on that transatlantic airspace between Europe and North America.
So sum it up for me, Paul. What does it mean for passengers mid-century? What does it mean for the aviation sector mid-century?
I think by the middle of this century, passengers can expect their flights to get bumpier, which for some people won't bother them. Maybe a drink or two will get spilt over. But for some passengers, it may be enough to put them off flying, especially nervous passengers. And for the aviation sector, I think it's certainly plausible that if flights get diverted more to fly around turbulence rather than through it, then of course the amount of fuel that needs to be burnt will increase, and fuel costs money, which airlines have to pay, and ultimately it could of course be passengers buying their tickets who see the prices go up.